Space is an ocean of superfluid vacuum, and spacecraft can swim in it like fish. This is consistent with relativity and is based on fluid dynamics, which manifests in the universe on micro and macro scales. In this hydrodynamic experiment, the hull of a boat with pendulums is rapidly displaced forward and slowly backward, creating propulsion due to an asymmetric pressure gradient in the water. For a long time, there was no unified theory describing the motion of this device. Classical theory of simple repulsion from water erroneously predicted that the direction of motion should be opposite to the observed one. The experiment filled this gap. When the boat hull is rapidly displaced forward, a trailing vortex forms behind it, and during the slow return motion, this vortex collides with the boat and imparts momentum to it. Thus, the boat pushes off from the vortices it creates itself. This experiment illustrates the classical problem of momentum conservation taking into account the added mass of water. A simple experiment can be performed. If you dip your palm in water and move it back and forth perpendicular to its plane, the resistance during the return motion will be noticeably greater. Imagine a homogeneous medium consisting of individual particles. The only possible arrangement of particles in an ideally homogeneous medium relative to each other is tetrahedrons or a triangular lattice in one plane. The particles interact with each other, attracting at a distance and repelling upon collision, due to molecular attraction and repulsion forces. Suppose particle 1 receives an impulse and moves toward two others. If these were billiard balls, the impulse would split in two. But in a fluid medium, molecular attraction and repulsion forces trigger a chain reaction like dominoes. Due to the system's constraints, the impulse circulates back to the first particle from both sides, leading to circulation. Thus, a vortex is a thermodynamic process arising from the self-organization of Brownian motion into a circulatory structure, whereby scattered thermal energy of the medium becomes locally concentrated and directed. This fundamental principle underlies the propulsion of all swimming and flying creatures, regardless of the configuration of their movements. For some fish species, this allows achieving anomalous efficiency up to 90%. In another experiment, there was 6 times greater air resistance on an oscillating plate than during steady flow in a wind tunnel, explained by the added mass of air. All this indicates that this principle of motion is understudied. Many modern studies view bird flight as a form of reactive propulsion, during which they shed vortices, creating thrust. This is analogous to the principle described above, and these vortices are impulses from vortex collapse reflected off the wing. The same environmental energy is responsible for the lift of an airplane wing, manifesting as vibration due to cyclic vortex processes. This phenomenon also allows rethinking quantum physics and cosmology. Vortices have a dual nature. They are localized in space and have momentum and mass like particles, but can also be represented as waves. Like an atom, a vortex can be described as a rotor with orbitals, where density gradients form a three-dimensional standing wave. External influence changes the vortex configuration, similar to an atom transitioning to another energy level. At high energy, a vortex ring approaches a spherical shape with a toroidal structure inside, as observed in the collapse of cavitation bubbles. Spiral structures of galaxies, resembling whirlpools, can be considered as projections of a toroidal vortex onto a plane. The involvement of medium energy in vortex formation corresponds to E equals mc squared. It becomes evident that fluid dynamics is one of the manifestations of the universe's fundamental principles, and by studying fluids, we can understand much else. Modern physics seeks to unify quantum mechanics, general relativity, and electromagnetism, as well as explain the nature of matter and gravity. In the superfluid vacuum theory, spacetime is reinterpreted as a superfluid subatomic medium, where magnetic fields arise as vortices, electric fields as pressure gradients, and matter as local inhomogeneities in these vortices. Superfluidity ensures the stability and quantization of vortices, as observed in superfluid helium. It can be assumed that gravitational waves create stresses in the superfluid vacuum, leading to ruptures in the formation of caverns, zones of reduced pressure. Spiral waves from the galactic center reach critical stress, causing cavitation in them and forming arms. Intergalactic gas filaments are the initial stage of matter emergence, similar to cavitation threads when water is exposed to ultrasound. Emerging from cavern collapse, a vortex is a region of lower density relative to the surrounding medium. A finite volume of medium containing a vortex occupies more space, corresponding to the universe's expansion. Thus, the universe's expansion equals the volume of new matter. In this case, gravity is a derivative of electromagnetic dipole interactions, resulting in interdependent asymmetric oscillations leading to fluctuations in matter attraction. At short distances, these fluctuations intensify due to mutual shielding. This explains interatomic attraction and gravity as a unified electromagnetic force. This opens up new possibilities for the design of aircraft and spacecraft. If issues of material durability, efficient drive, a powerful energy source and control will be resolved, it might be possible to create an biomechanical aircraft that, by powerfully shell oscillating, turn air into condensation or plasma cloud. Such craft realizes as a gas-filled hull, mimicking marine fauna. The use of a light gas minimizes mass of the craft and transforms its internal volume into an acoustic chamber, distributing resonant oscillations across the entire surface area. This concept combines the advantages of an airplane, an airship, and a jet engine that uses a medium as a propellant. The craft accelerates in the atmosphere and, due to the massive surface area interacting with the rarefied medium, transitions to low orbit. Upon the disappearance of a gaseous medium, mechanical oscillations are shifted to ultra-high frequencies to emit photons or virtual photons, which is theoretically possible and is called mechanoluminescence.